Welcome back to our party video. This is our final video of paper 4 of your Maths 21, and we'll be solving those remaining questions we didn't do that before, and I'll be also guiding you how to do well in your examination, and also about question pattern we'll be discussing. So before I think we have solved up to question number 7. I'm not sure about it. Let's check it once. Oh, 4 number already done. 6 number. Oh, 7 number. So these things we already solved this question number 7a. So now question number 7ii. So what is asked in these questions? Let's see. So at time equals to 0, the input potential B in is 0. B in then gradually increases with the time t as shown in figure 7.2. So how much gain we have? 6.0 gain. So potential. So what you have to do is so let me see. So in these questions, first let's zoom it. Zoom in. Alright, pen selected. Okay. So we have got amplifier 3. So up to here. Okay. And from here, just to make a straight line like this and a straight line. Okay. This is actually a straight line. Not measured. And so state how the circuit of figure 7.2 may be changed so that gain of the amplifier is dependent on light intensity. So what can be the answer? Replace 3.6 kilo ohm by your LDR. So you can write it here, 3.6 kilohertz. So let me replace 3.6 kilo ohm by or LDR. Okay. And next one is an op-amp is to be used to switch a high voltage heater. State the name of component used as output device of the op-amp. So and then after answer will be relay, I guess, but it's relay. Okay, answer is relay. Actually, don't get confused about it. And the next question is complete figure 7.3 using the device named in 1. So relay. So you have to put the relay over here. So I think you have already done this in physics. Here will be make a symbol of relay, and here one switch. A switch. Okay, careful switch. And then after like this one, this dot dot dot. Okay, don't dot 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 in square. No, rectangle. Okay, fine. So you cover 9 marks. Very simple question. Oh, so two long straight wires P and Q are parallel to each other as shown in figure 8.1. There is a current in each wire in the direction shown. The pattern of the magnetic field lines in a plane normal to wire P due to the current in the wire is also shown. So draw arrows on the magnetic field lines in figure 8.1 around wire P2 so the direction of the field. So it's very simple. Use Fleming thumb rule, and the direction will be like this. Okay, just use Fleming thumb rule. And also, so where is okay, determine the direction of the force on wire Q to the magnetic field towards the wire P. Towards the wire P. Towards the wire P. Towards the wire P. So while having figures, it will be a straight line. This must be perpendicular towards wire P. Okay, this is F, not P. A lot of time I get confused. Okay, And now um, another question is state and explain whether the magnitude of the force on wire P is less than, equal to, or greater than magnitude of the force, because the current in wire Q is less than the current in the P. So here what is current in the wire P is greater than Q. So what will happen, you know, the concept that uh, B is D, right? With D, that is B is when the uh, increase, and then after the F equals to BIL, and then after, so force on B is greater than force on Q. This is P, sorry, not B. So force on Q is greater than force on Q. So this is for 2 marks. And if you get any confused, then I would suggest you to go through David Sang book. So here, nuclear magnetic resonance, NMRI, is used to obtain diagnostic information about internal structure in the human body. Radio waves are produced, don't look answer, produced and directed towards the body. It means radio waves are actually directed towards the body, your body, okay, your stomach. The radio waves affect the proteins within the body. So it affects is actually to something in your body. And why radio waves are used? Because frequency of precision in the range of frequency, radio frequency are non-harmful. You can also write like that, but when radio frequency pulses are applied, the nuclear resonance, and on relaxations, nuclear re-emit pulses. I would suggest for this one to go through David Sang book. Okay, I'll also mention here David Sang book. There you can see a well answer. Explain why the radio waves are applied in pulses to distinguish the incident and re-emitted pulses from different positions. Pulses are detected between two incident pulses. Same thing, David Sang book. I'm not expert in this field actually. So definitions you can do it your own. So here the numerical came. Calculate the maximum magnitude of the induced electromotive force in the solenoid. So this question has asked to find the maximum magnitude. So how can we do this? Okay, so induced MF, you know, like formula for induced EMF, that is N divided by time, and the maximum we have got here is what is that? What is this is 250. Okay, this is 250, right? This maximum one, and the BAN, that is like 540. You know the formula of this 540. So 6 by 10 into 10 to the power minus 2 whole square times 250, because so I would suggest you to print out these questions and see the questions. Okay, so I'm actually writing answer here. I'm not describing the part like so. Fine. The answer will be 0.32, 3 marks. Seems like tough, but don't panic. The questions are very easy. And here, a copper sheet is supported on a rigid rod so that it hangs between the poles of magnet as shown in the figure. So actually this is a copper rod, and when this move like oscillate, and it is replaced by this sheet. X is replaced by this one copper sheet, which have this bar one, and the question has, and this seems like damping, light damping, I could say. This is light damping. And what is the, oh, is it the name of phenomena? Oh, light damping. Light damping. So deduce which copper sheet is represented by the dashed line. Explain your answer using the principle of electromagnetic inductions. If you do not know the concept of electromagnetic inductions, then go to YouTube and get some idea about electromagnetic inductions and jump into this question, because this question is about 4 marks, pretty tough. So answer is copper sheet. When the copper sheet oscillate, I told you it caught magnetic flux. The induced EMF are induced in copper sheets. Eddy current, induced current, are induced in copper sheet. The current has heating effect, and this heat loss is from the oscillation system. Due to the eddy current in copper sheet, Y is much smaller than that in copper sheet X. So for X, more heat loss, more energy loss, and more decrease in amplitude. 4 marks. But this is actually for 5 marks. You can write like this. Oh, here, electric current. Um, so I would suggest, well, we know that this is actually B naught, yeah, and this is theta. Oh, so determine the root mean square. The root mean square, you know the formula, BRMS, BRMS, BRMS. We have got B naught by formula, you know that. So 320. I'm actually looking questions. I have got printed one, but I would suggest you to print out this. I'll also mention these solved answers file in descriptions. You can also look from there if you get any confused. Okay, 2 to 6. You are free to comment if you get any confusions. I'll respond. Determine the time period. Time period. We know the time period T equals to 2 pi over omega. If you do not know this one, then I would say you are the most stupid people who haven't studied electric current yet. I don't want to like select these things. Sorry. Okay, so 2 pi omega, we have got 100 pi. Okay, no, actually this is, sorry, this is omega. Yeah, exactly, this is omega. I'm sorry. Okay, omega. So omega gives out 0.02. So answer is 0.02. All right. And the power supply is connected to resistor R and a diode in the current shown in figure. So what this question is asked to is state name the type of rectification. And you also need a rectification. These half-wave rectifications, half wave. So on the figure, scales variation with time, T PDR across T, variation with time. So time is like, what is variation with time? I think 300, I could say. We have got time period 0.02. So it should have gap of 0.02. Then the figure seems like this. Oh, properly, okay. And this, yeah. You got how much? 3 marks. Oh, draw symbol for component that may be connected to produce smoothing. So you have already done this several times, putting capacitors between this circuit. It's very simple. Oh, this covers how much? 8 marks. Oh, here, electrons are accelerated through a potential difference of 15 kilovolt. So what are you going to write? Explain why a continuous spectrum of energy of X-ray photons is produced. For this one also, I would suggest you to study medical physics. There you'll get X-ray about the exact answers. It's pretty long. So this, I'm actually doing it in short form. So due to breaking radiation, that brimstone radiations that scientist one named it, an electron get excited. If you write this point also, you will get full marks. Don't worry about it. Excited, electrons get excited state. And the final one is due to high potential difference. So if you just write this point also, then you will get I could say 3 marks, 3 out of 3. So calculate the wavelength of highest energy active photon. So we have got 15 kilowatt volt, that is our PD. So you know this energy equals to SC by F. So frequency, oh sorry, so no, lambda, and when we calculate for lambda it will be this, and from here 6.63 Planck constant, okay, times the speed of light, that is 10 to the power 8, down E, how much? 2.4, 10 to the power minus 3. So how are you going to calculate E? Is by using this time for formula. Don't worry, okay, you can get it from here, and that is 8.293, the answers. Alright, the next questions. X-rays initialize directly into the some body tissues after passing through a thickness X tissue of the X. So this is graph of X-ray, and this is actually, I think you remember this part, okay. This is actually about like this one. So you have this I equals to I naught e to the power mu x. So from here you can have, so e to the power mu x, when you do ln it will be like this one. No, sorry, this is be mu minus mu x. So this is minus mu x. So I'll make it clear. This will seems minus mu x, and you get the value of this. So wait, how much we have got? Where is the answer?